Hello everyone, I am Deebadharshini. I am PG scholar in Stella College here to present my survey report. I hope my screen is visible. Okay, the index of this content are introduction and then the literature review that speaks about data sets and neural networks and then the conclusion part. Okay, introduction. Robotics is an important field of research nowadays. We invented robots to ease out human work to perform tasks that could not be done by humans or to use them in tasks that are dangerous to humans. As they mean to do human activities, it is important for them to have capabilities like us. It is very important to work on the vision of robots to make them as similar as human vision. This area of artificial intelligence is called computer vision. In robotics, the visual inputs are given as image or video. Understanding the objects is called like object recognition. What is that object is, and analyzing the location, size, and position of the object is called object detection. The object detection is used in various applications like vehicle tracking systems, self-driving cars, surveillance cameras, and so on. The output of the object detection contains boundary boxes around the object with the name and accuracy percentage. Okay. Initially, the object detection was done through three steps. The first step chooses the region of the information. The second step extracts a feature from the data, and at last, finally, the objects are classified. As the object detection process becomes complex, we use a deep learning approach called convolutional neural network. This CNN has combined layers of convolutional network, which is a type of feed-forward neural network. Initially, the given object's pixels are converted as 1 or minus 1, where 1 is put in in the object's position and minus 1 is put in the space or background or the area that we do not wish to consider. Now, as an object we train, the actual existence of the object doesn't match. Instead of comparing the whole object, we take like when we try to compare the object with the object that is there in our database, that will not match because the objects that exist in the real world are not the same as the object that we train. Like not in every cases. So So instead of comparing the whole object, we take piece by piece to match the features. Now we enter into the first layer called convolutional layer in the CNN. In this area, we create a map of values which is obtained by the average of numerator holding the multiplied pixel values of picture image. No, sorry, feature image and the actual image. Actual image is the image that the robot is looking at, and denominator having the total number of pixels. For this process done to all face of the image, next is the rectified linear unit, which is simply called as ReLU layer. So first we in the convolution layer will get an minimalized version of that image. So in this ReLU layer, that removes every negative values from the filtered image and it replaces it with zero. The next layer is a pooling layer that shrinks the image stack into a smaller size by moving the slide across filtered image and takes the maximum value out of it. Finally, in the fully connected layer, the filtered and shrinked image is put into a single list. Now we compare this list and the list of trained image to classify them. This is how CNN works. We face few problems in CNN like aspect ratios and spatial locations. So the improvised version of CNN is introduced called RCNN, is a region-based convolutional network. The RCNN took more time to process the inputs. So fast RCNN introduced, and because of the few drawbacks in fast RCNN, then the faster RCNN is introduced. So to improve identification accuracy, another framework is also introduced with under Southern. This is called mask RCNN. That defines objects by masking them through bounding pixels. This is all about the introduction. Next, we'll move on to the literature survey. Okay, the literature survey speaks about two things. One is the data sets and the neural networks that is associated with this object detection or that or those research that has happened earlier. Okay, so first our data sets. Okay, before uh, So before we start looking into these neural network techniques, it is important for us to be aware of datasets that is used to train the object detection model. The three important widely used datasets are ImageNet, Pascal Walk, and Microsoft Coco. Based on the project we choose, we could also create our own database that is required for us. Okay, I'll tell you a brief view of these datasets. ImageNet is a widely used dataset as it contains 14 million images that is categorized into 21K classes approximately. And for 2 million images, the annotations are provided. Annotations is in the case the labels of that object. Okay, this is a standard dataset to perform algorithms of deep learning. Next is the Pascal walk. I mean, the abbreviation of this term is uh, pattern analysis, statistical modeling, and computational learning. This dataset has 15K annotated images with 20 categories. This dataset is smaller than imaging, but this is mostly used for classification or semantic segmentation detection of objects. Next comes the Microsoft Coco. Coco is insane. The full form of Coco is Common Objects in the Context. It is the latest dataset sponsored by Microsoft. This has 30 lakh images approximately, which is categorized into 80 to 90 classes and has 2 lakh annotated pictures. Okay, so now we will look into the first neural network RCNN. This works based on a selective search algorithm. This proposes a bounding box for all objects in the image, and then it extracts features extractions of each boxes. Instead of look into all the boxes, it combines overlaying a small boxes to a single bounding box by giving threshold values, and this is done by using greedy approach. This process happens in four steps. In the first process, input image is given. Next, it extracts to those regions of rectangular boxes. In the third step, the features are extracted using convolutional layers. And finally, based on the extracted features, they are classified in the appropriate classes. So it classifies images perfectly. It has drawbacks such as log loss, long waiting time because of multi-stage training nature, expensive space and time utilization. So to repair these drawbacks, spatial pyramid pooling networks were used. This computes multiple pooling layers and results in reduced training time and faster feature extraction. So this is all about RCNN. Next is fast RCNN. So RCNN had few drawbacks, and those drawbacks were treated using SPP net. They had disadvantages. To fix these disadvantages, a new method called fast RCNN was introduced by Los Vegas. The new improvement in this method is instead of generating what is that new improvement is done here is instead of generating a rectangular box for all objects, it uses selective search approach to generate particular region of interest, simply called ROI. This segmentation is done on the basis of pixels depths in the graph format. RCN has three-step process, uh, but but here we use only one model where the image is directly sent to the networks. This produces two layers of for every object. The first layer classifies the object, and the second layer gives a softmax probability that yield four real values for the generation of bounding box regression. And this fast RCN has many advantages like high quality detection than previous methods. Feature storage do not require disk storage and others. The text speed is 10x faster, and sorry, the test speed is 10x faster, and the training speed is 3 into faster than RCN with SPP. SPP is spatial pyramid neural networks. Okay. So now we'll move into faster RCNN. Next comes the fast RCNN. We have seen like fast RCNN achieves fast feature extraction, but there it took time for processing proposing regions that was took into point. That was not took into point. Shakung, Rent and team made a change in fast RCNN and proposed a new model called faster RCNN that introduced another deep CNN called Region Proportional Network to get efficient solution. So by introducing this RPN with the already existing network, the cost for computing region proportions were reduced. The first component in this architecture is that RPN that produces rectangular boxes and then fully connected layer, which is fed into two parallel layers called box segmentation and box classified. Here we have a mini network that works as a sliding window. That is moved enters to a spatial location of the input. This faster ascending method is the one that was used widely for a period of time. Next comes is the mass RCN. Uh, Okay, so next mask RCN, which is quite different in the way that it gives output. The previous work, like it has framed bounding boxes of the input. This method identify objects in an accurate way by masking the objects through pixel boundaries over the outline. This is done by adding another layer called as mark layer that is put in each ROI in fully connected layer, mask layer. So this mask layer is different from other layers because the pixel extraction should be thinner spatial layout of the object, so to accurately identify the structure of the object. So beside classification layer and bounding box layer, the output also gives a binary mask for each for every region of interest after extracting features. A standard activity called ROI, which progresses the quantization of ROI pool. ROI is nothing but the region of interest pool to properly align the opt-in features of the input. And this is how mass casting works. And next is a CNN with SVM. This is another mechanism called support vector mission SVM. Is used with CNN to classify features. This method has two types. That is linear separable, and the other one is non-linear separable. This is a There is an hyper plane is a kind of line that is drawn between points to classify them in two sectors. The concept here is two lines that are drawn parallel in opposite sides from the hyperplane are called margins. And these margins are extended till it reaches a point. When the margin touches the nearest point, the point that is on the margin line is called nearest positive point, and the other side nearest negative point. Is this how it works? And next is YOLO. Next comes a very important and latest technique called YOLO. You look only once is a presently used method for object detection. We write this using Python language. This method is used in real-time object detection and is an open source tool. There are many versions in this. This accomplishes object detection through fixed grid regression, and based on the class probability mapping, it gives a final decision. So, the advantages include here is it is fast and gives good real-time accuracy. YOLO has few limitations, like it has strong spatial constraints that detects even small objects in the group. Identifying it's a difficulty in generalizing, and while dealing with errors, it doesn't treat small and large boundary box in a similar way. Okay. So these are all the networks of neural networks of these neural network techniques that is used in object detection. So at last, I'd like to conclude by telling there are various deep learning procedures available to detect objects. So in this paper, I have discussed various techniques of CNM. The learning methods or content over here is uh, though base method could detect objects, we move on to one stage detectors to decrease the complexity and increase the pace and accuracy. I conclude by telling there is no aim to make innovations and make changes to create new techniques. Uh, okay, thank you.